So, homework 32 starts out and it talks about the domain of a rational function. When they're asking you about the domain of something, they're trying to find out what kind of answers or what kind of numbers you can put in for x and get a real number answer. What they want you to know on this one is that your denominator can never equal 0, right? If you have 0 on the bottom of a fraction, you get a math error. If you take your calculator and you try to do a fraction like 5 over 0, it's going to give you a math error because the bottom of your fraction can't ever be 0. And so when they ask you about the domain of a rational expression, they're talking about a fraction, and what you're going to do is you're going to look at the bottom of the fraction, which in this case is the x squared plus 5x plus 4, and you're going to say, oh, I know that on the bottom of the fraction I can't ever have a 0. We're going to solve this one by factoring since it has the squared term in it. So last week Jane worked with you on factoring. So we're going to factor that out with our two sets of parentheses. We know it came from FOILing. We factor the leading term. What times what gives me x squared? X and x. Since both of my signs are pluses, tells me both of my signs are going to be pluses down here. Plus and a plus. So I want the factors of the n number 4 that add up to the 5 in the middle. What pair of factors for 4 add up to 5?
4 and 1.
4 and 1, exactly. And then we're going to just break it into two separate problems. Either the x plus 4 can't equal 0 or the x plus 1 can't equal 0. And so when we solve each of those, we're just moving our number to the opposite side, which changes our sign. So here, x can't equal a negative 4, and over here, moving my number, x can't equal a negative 1. Since in the question it asks which ones are not in the domain, they're not going to use the not equal sign. They're just going to say, oh, what two numbers can't x equal? Negative 4 and negative 1. So number 2, same kind of thing. We want to find the values that are not in the domain of h. H is a fraction, and we know that with fractions, the denominator of our fraction, x squared minus 17x plus 72, can never equal 0. Again, on this one, we have one of those quadratic expressions with the squared term that we have to solve by factoring out. So we use our two sets of parentheses. Factors of x squared, x and x. This time on my signs, the end is positive, but the middle is negative. I know if the end is positive, both signs have to be the same, so they're the same as the middle. So I'm going to have a negative times a negative. Right? A negative times a negative is a positive, and I add up to a negative in the middle. So this time I want the factors of 72 that are going to add up to the negative 17 in the middle. 9 and 8. A negative 9 times a negative 8 is the positive 72 on the end. Negative 8x plus the negative 9x gives me the negative 17x in the middle. Again, we're going to say that the x minus 9 can't equal 0, and then the x minus 8 can't equal 0, but we got to move our numbers over so we get the opposite answers. And so the two values that are not going to be in my domain would be what two numbers?
9 and 8.
Positive 9 and positive 8. So third one, same kind of thing. I want to find the values that are not in the domain of g. We know we have a fraction. We know that in the fraction, the denominator, the x squared minus 1, can't be equal to 0. Again, this one does have the squared term, so we know that it came from factoring out using my two sets of parentheses. This one, maybe you recognize right away, is the difference of perfect squares. If not, you still factor it kind of the same way. Factors of x squared, x and x. If the n sign is a negative, I'm going to have a positive and a negative. And then the factors of 1 that give me 0 in the middle. Well, there's only one pair of factors for 1. 1 and 1. I get a negative 1x and a positive 1x, and that's why I have 0 x's in the middle when I FOIL that out. So again, we're going to set each of those and say they can't be equal to 0. Otherwise, I'd have 0 in the bottom of my fraction. I solve them by moving the numbers over to the other side. Put my 0 on that one. And so I'm going to minus my 1 here and plus my 1 here. So the two numbers that are not in the domain here, negative 1 and positive 1. Sometimes you will have ones where you don't have the squared term and you just move the number over and it's pretty easy to solve. But most of the time they like you to practice your factoring, which we're going to do on the next ones. So number 4, 5, and 6 wants us to simplify a ratio of polynomials. Ratio is another word they use for a fraction, just like a rational number is a fraction. A ratio of polynomials, I've got a fraction, polynomials on the top and on the bottom. If I'm going to simplify it, I need to factor it out so that I can cancel out my common factors. So when you did factoring with Jane, the first thing you did is you look for a greatest common factor. Is there something common to all of the terms in the polynomial? On the top one, I can divide both of those by 4. So my first step is to put the 4 out in front and divide the 4 out of both of my terms. So 4u squared, if I take the 4 out, I just get the u squared. Negative 100 divided by 4 would be minus 25. Now if I look at the bottom 3 terms, they don't have anything in common other than a 1, so I can't take out a greatest common factor there. Then I'm going to go to factoring my squared part of it. So on the top part of it, I still have the 4, but I've got to factor what's left in the parentheses. And again, hopefully you recognize that as the difference of perfect squares, because if you do, it makes it easier to know what to do to factor it. Factors of u squared, u and u. Since the end is negative, my signs, a positive and a negative, and the factors of 25 that are going to give me 0 in the middle, a positive 5 and a negative 5, right? 5 minus 5 is 0. The bottom, we didn't have a greatest common factor, but it is a quadratic expression, has that squared term, so we know we can factor it out by using our 2 sets of parentheses. Factors of u squared. U and u. My signs, if the end is positive, both have to be the same as the middle, so I'm going to have a negative and a negative. Factors of 15 that are going to give me that negative 8 in the middle. 3 and 5. What you should notice is that one pair of those factors is the same. We can then cancel it out of our fraction. In this case, we can cancel out the u minus 5s. So my answer is going to be 4 times u plus 5 on the top. On the bottom you have the u minus 3. You really don't need the parentheses since it's no longer times anything. And we're going to leave our answer like that in factored form. You don't need to multiply the 4 times the u plus 5 out on top. Yeah, I suppose you could if you really wanted to, but that'd just be more work. So number 5, my first step, looking for my greatest common factors on the top. I do have a greatest common factor. What would it be? 6. I can divide both of those terms by 6. So 6 in front. If I divide each of those by 6, 6w squared divided by 6 is w squared. And then 6 divided by 6 is 1. So I get w squared minus 1 in my parentheses. Bottom, looking at that, no greatest common factor, so I skip to the next step. So the next step is factoring my quadratic expressions. I still have the 6. I've got to factor my w squared minus 1, which is the difference of perfect squares. That factors into what? W and W,
Positive
positive and
and negative.
a negative, and 1, right? Plus 1 and a minus 1 give me 0 in the middle. On the bottom, factoring that quadratic expression, W squared minus 5W minus 6. So factors of W squared, W and W. This time my signs are going to be
Negative.
a negative and a positive. Since the end is negative, you've got one of each, whichever order you want to put them down, just so you got 1 plus and 1 minus. And then you want the factors of 6 that when you add them up, you're going to get that negative 5. You've got 1 plus and 1 minus. So which pair can I put in there to get minus 5?
6 and 5.
A minus 6 and a
1.
plus 1. That's what you meant, right?
Yeah.
Negative 6 plus 1 is negative 5 in the middle. My common factor then is the W plus 1. We can get rid of that from our expression. So on the top we have 6 times W minus 1. On the bottom, W minus 6. And we've simplified our fraction as much as we can. Number 6, looking at that one. If I look at the top of my expression, I don't have a greatest common factor that I can take out, but if I look at the bottom of my fraction, I can divide all of those by 4. So I'm going to take the 4 out of all of those from the bottom, and when I divide each of those by 4, I would get
U squared minus U minus 28.
dividing by 4.
Oh.
12. So I get U squared minus U minus 12 in my parentheses. We can then jump over to the next step. On the top, I have a quadratic expression, so I have my 2 sets of parentheses. Factors of U squared, U and U. My signs on this one.
Negative?
A negative and a,
Negative?
nope.
Oh.
Since the end is negative, I'm going to have
Um,
one of each, 1 positive and 1 negative. If I'm going to have both negative, the end has to be positive and the middle is negative. So if the end is negative, we've got 1 positive and 1 negative. Factors of 24, that's going to give me that positive 2 in the middle.
Six and 4.
6 and 4. We need a plus 6 and a minus 4. Positive 6 minus 4 is a positive 2. On the bottom, we've got the 4 out in front. Then we've got to factor the U squared minus U minus 12. So again, factors of U squared, U and U. My signs,
Negative and a positive.
a negative and a positive. Since the end is negative, I've got one of each. And I want the factors of 12 that when I plug it in, I get a minus 1 U in the middle, right? A minus U is a minus 1 U. So what pair of factors can we use for 12?
Oh, 1.
Nope. 12 and 1 would give us 11 in the middle. My choices for 12, 1 times 12, 2 times 6, or 3 times 4, right?
4 is 3.
The 4 and the 3. I need to have a minus 4 and a plus 3 to add up to minus 1. My common factor, U minus 4, we can cancel that out of there. And so on the top we have U plus 6. On the bottom we have 4 times U plus 3. 7, 8, and 9 tell us to simplify our ratio of multivariate polynomials. Ratio, again, just tells me I have a fraction. Multivariate, there's more than one variable, and we've got polynomials up there. When I'm simplifying this, basically all I'm doing is reducing it down. I'm looking to see of all of my terms, what are my greatest common factors. So I'm going to look at my numbers first. I have a 4, I have an 8, I have a 12. All of those are divisible by 4. So I'm just going to reduce them all down by 4. This is going to cancel out, this is going to become 2, and that's going to become 3. Then I'm looking at my u's. I've got a u to the 6th, a u to the 5th, and a u to the 3rd. My greatest common factor there is u to the 3rd. You always do the lowest exponent because you can't take out more than you have. When you divide that out, you subtract your exponents. So here, 6 minus 3 would give me u to the 3rd. Here, 5 minus 3 would give me u to the 2nd. And here, 3 minus 3 cancels out. Now, even though I have w and x's, I don't have that in all 3 terms, so I can't cancel any of those out. So my final answer here, my first term, I'm going to have u to the 3rd, w to the 4th, plus 2u squared x to the 6th. And on the bottom, just the 3. So number 8, if I'm going to simplify that fraction, I'm going to divide out my greatest common factor. So 15, 9, and 9 are all divisible by 3. So I'm going to reduce all those down by 3. 3 goes into 15 5 times, into 9 3 times, and into that 9 3 times. Look, I don't have w's in all 3 terms, but I do have y's in all 3 terms. I've got a y to the 4th, a y, and a y to the 3rd. So my greatest common factor there is, what was that? 2. Can I take 2 out of a y?
No.
Nope.
Oh, just a 1.
It's just the y. So if I have 4 here, 1 here, and 3 here, I can only take 1 out of each term. So 4 minus 1 would give me y to the 3rd. 1 minus 1, that's going to cancel that y out of there. 3 minus 1 is going to give me y to the 2nd. So my first term, I've got 5. I've got that little w smushed in there. Y to the 3rd. Plus my second term, just have the 3 left. And on the bottom, I've got a 3, u to the 4th, and y squared. So 5wy cubed plus 3 over 3u to the 4th y squared. Oops, throwing that on the floor. So number 9, I'm going to simplify that. What can I divide out of 9, 15, and 9? 3 again. So, I'm going to divide that. I get 3. Here I'm going to get 5. And here I'm going to get 3. Then if I look at my variables, what can I take out for variables?
X.
Just an x. There's an x in all 3 terms, and x to the 1st is my lowest exponent. So if I take x out of here, I get x to the 3rd. The x out of there, it cancels out. And the x out of there, I get x to the 2nd, subtracting 1 off of each of those. And so my answer is going to be what?
3w x to the 3rd over 5u to the 4th minus 3x squared.
Exactly. So 3wx cubed over 5u to the 4th minus 3x squared. So just reducing it down. 10, 11, 12, they're talking about multiplying rational expressions, and when I multiply fractions, I got to keep in mind that I can cancel out my common factors. I usually like to just start with the numbers first because sometimes there's multiple variables in there that we can combine. So I'm just going to start and say, okay, I can reduce the 7 and the 14. 7 goes into here once and into 14 2 times. I'm then going to go ahead and multiply the top together and multiply the bottom together. And so on the top, 2 times 2 is 4. I've got a b to the 5th, and then I've got a c times another c, so that would be c to the 2nd power. On the bottom, I've got a c to the 3rd and a b squared, but because I like to line them up because I'm going to cancel, I'm going to switch them around, and I'm going to put the b squared first and the c to the 3rd. So they're in alphabetical order. Not that you have to do that, but it just makes it easier to see what you're doing. Then all I'm going to do is cancel out my common factors on my variable. I've got a b to the 5th and a b to the 3rd on the bottom, or b to the 2nd on the bottom. I can take out the b squared, which leaves me b to the 3rd. I've got a c to the 2nd on top, c to the 3rd on the bottom. I can take out the c squared, which leaves me a c to the 1st, or just c on the bottom. So my answer, I've got a 4b to the 3rd on the top and a plain old c on the bottom. And you can do all your canceling all the way at the beginning, but I find that people miss that extra variable that's sometimes smushed in there, and that's why I do it in that order. So I just start out, I'm going to do my numbers first. So the 2 and the 4 can be reduced down. 2 goes in there once, into there 2 times. The 5 and the 15 can also be reduced. 5 goes into 5 once and into 15 3 times. So on the top I'm going to have 3. I have a b to the 5th. And then I've got a y and a y squared. Y times y squared, y to the 3rd. On the bottom I've got a 2. And then I just have a plain b and a plain y, by. Canceling out my variables there. I've got a b to the 5th on the top and a b on the bottom. I can only take off one b, which leaves me a b to the 4th up on top. I've got a y to the 3rd on the top and a plain y on the bottom. Again, I can just take out one of my y's, which leaves me y to the 2nd on top. So my answer there would be 3b to the 4th y squared over 2. Number 12 then, if I'm going to simplify that, what do I want to do first? Okay, 2 goes into here once and into here 3 times.
And then the 5.
And then the 5 goes into 5 once and into 10 2 times. So on the top I'm going to have 2ax, and on the bottom I'm going to have 3ax squared, because there's an x and another x, right? So x and x would be x squared. So canceling on my variables, what can I cancel out of there? I can cancel out the a's, which means those are gone altogether.
And then just leave one on there.
One x on the bottom. So my answer, 2 over 3x then. And the, oh no, not the last 3. It's a little longer than I thought it was. The next 3, multiplying, simplify your answer as much as possible. So we found out on the previous ones you can cancel out your common factors that you have between the top and the bottom, but the first thing you need to do is factor out the tops and the bottoms so that you can cancel. So on the top of this fraction, it doesn't have any squareds, it doesn't have any greatest common factors. I can't do anything with that x minus 1. I'm just going to leave it alone. On the bottom of my first fraction, I do have that quadratic expression that I can factor out by FOILing, putting my two sets of parentheses. Factors of x squared, x and x. The m sign is a negative, so we know we have 1 plus and 1 minus. We want the factors of 6 that when we plug them in, it adds up to the negative 1 in the middle. So we would use what for our factors?
2 and 3.
2 and 3. Plus 2 and minus 3 add up to the minus 1 in the middle. On the top of the second fraction, doesn't have the squared, but it does have a greatest common factor of 4. So I'm going to take the 4, put it in front, and divide each of those by 4. 4x divided by 4 gives me an x, and 8 divided by 4 is 2. The bottom of that second fraction doesn't have a square, doesn't have a greatest common factor, can't do anything with it, so I just leave it as x minus 2. Once I have it in factored form, I look to see, do I have any common factors that one is on the top and one is on the bottom? In this case, I only have one pair, the x plus 2. So I can get rid of the x plus 2. And so when I write my answer, normally they'll put any lone numbers out in front, so they'll put the 4 times the x minus 1 on top. On the bottom, we have both an x minus 3 and an x minus 2. And since those are binomials, we've got to put them in parentheses. And so my answer would look like that. So number 14, same kind of thing. The x minus 2, I can't do any factoring on, so I'm going to leave it as x minus 2. On the bottom part, 3x plus 3, I can divide both of those by 3, and I'd have 3 times x plus 1. I divide both those by 3. Top of the second fraction, we know that one came from FOILing something else, so if we factor that, we know we have x and x. My signs, both positive. Since the end is positive, they're both the same as the middle, but if they're all pluses, they're going to be pluses. Factors of 2 that add up to 3. 2 and 1. On the bottom, again, we have that quadratic expression, factoring x and x. This time my signs are a positive and a negative, and we want the factors of 6 that give us a plus 1 in the middle.
2 and 3.
And I want which one by the plus?
3.
The 3. Plus 3 and minus 2. Positive 3 minus 2 is a positive 1. So, what can we cancel out of there?
X minus 2.
We can take out the x minus 2, and we can also do
X plus 1.
an x plus 1. And so on the top, we're left with an x plus 2. Don't need the parentheses since it's not times anything else. On the bottom, we have a 3 times an x plus 3. And there would be our answer, as simplified as much as we can. So number 15, same kind of thing. If I'm going to factor the top of that fraction, how does that factor? I like 6 today.
X and then there's going to be a plus and minus.
XX plus and a minus. Plus 3 and a minus 2. 3 minus 2 is the 1x in the middle. Bottom of that first fraction, can't do anything with that. It doesn't have a squared and it doesn't have a greatest common factor. However, the top of the next fraction, we can factor that. What can we do with that? 4 times x plus 1. Factoring out the greatest common factor of 4. And the bottom of that second fraction is a quadratic one, so we know we got our two sets of parentheses. It happens to be the difference of perfect squares. How does that factor? X what? Plus and a minus, yep. X plus and X minus 3 and 3, right? Positive 3 and a negative 3 is the 0 X's that we have in the middle. So on this one, we can cancel out X plus 3 and X plus 1. So our answer, 4 times X minus 2 over X minus 3. And then the last three on this page have to do with dividing fractions. So when we divide fractions, we have to invert the second fraction and multiply. So we're going to change this problem into 5a to the 5th x over 4x to the 5th, leaving the first fraction alone, but then we have to multiply by the reciprocal of the second fraction. So 8x over a to the 3rd. I usually like to work with my numbers first. I can't cancel the 5 with anything, but I can reduce the 4 and the 8. 4 goes into there once and into there twice. Then I like to multiply across the top. 5 times 2 is 10. I have an a to the 5th. And then I have an x and another x, so x squared. On the bottom, we've canceled the 4, so I have an a to the 3rd and an x to the 5th. And then canceling out my variables, I can cancel out the a to the 3rd and the x to the 2nd. So if I take a to the 3rd out of there, it leaves me an a squared up on top. 5 minus 3 is 2. If I take out the x squared, I'm going to take 2 off of 5, so I get x to the 3rd on the bottom. So I get 10a squared over x cubed for my answer. So number 17 here. Again, we're dividing fractions, so we have to invert and multiply. So we're going to take the 2y to the 2y over 5b, if I read it right, times the reciprocal 15b to the 5th y squared over 4y. So what can we do with that one? Cancel the 5. 5 goes into 5 once and into 15 3 times. And the 2. 2 goes into 2 once and into 4 2 times. So on the top we would get
15. Wait, no. I didn't do it. Usually b to the 5th y and the 3rd over 2by.
3b to the 5th y to the, whoops, 3rd. You said 3rd.
Yeah.
And I wrote 2nd. 3rd.
2by.
And 2by. So on there we can cancel out
1b and 1y.
1b and 1y. So we have a b to the 4th and a y to the 2nd. So we get 3b to the 4th y squared over just a plain old 2. And one last one on this page. So again, we are dividing fractions. We have to invert and multiply. So 8x to the 3rd y to the 4th over 9y times the reciprocal 3y over 4x. What can we do with that one?
2 goes into 4 twice, or 4 goes into 8 twice,
So
and then 3 goes into 9.
So we can cancel out 4 and we can cancel out 3's. So on the top we're going to have
2x to the third y to the fifth.
2x to the third, y to the fifth, and on the bottom
3xy.
3xy. We can then cancel out
1x, 1y.
1x and 1y. And so our answer,
2x squared y to the fourth over 3.
and there it is. Alrighty, that should be the first 6 things then in chapter 6.